So good afternoon. As before, my name is Sandy Baritsa and this is the continuation of the exercises for Evolutionary Robotics at Faculty of Engineering in Rijeka. So in the last exercise we have created our BubbleRobot here. To be more precise, we have created its body, and now we're going to add some sensors to it to make it an actual functioning robot. So there are a couple of sensors that we can add. The initial sensor that we will add is going to be a simple graph. So we'll go here and we will add graph. Great, so this will write the XY position of the robot in our scene here once we have programmed it. That's the first example of the sensor. Now that sensor isn't terribly useful to us, but we can add some that are slightly bit more useful for weighting and similar actions. So we're going to go to the proximity sensor and we're going to add the cone type. So you can see our sensor has been added, and we are going to name it very simply BubbleRobot sensing. Now we can see that the position of this sensor isn't terribly useful to us. We want to make it an actual nose and add it here, so we're going to translate it. In the translation we're going to use the following parameters. We'll move it 15 centimeters to the front. We will leave the y coordinate as is, and we're going to lift it up by 1.15, so 0.115 meters. Okay, and now we can see that here we have the center, the source of our sensor is positioned in the point of the nose. That's obviously not terribly useful to us. We don't want it pointing up, so we're just going to rotate it by 90 degrees here. Great. Okay, so as is, the sensor has some issues. We don't want it hitting the floor here, and we need to adjust some other parameters for that. So we're going to go near its name, click on the icon next to it, and here we will have certain parameters that we can adjust. There are two main settings. We have volume and detection parameters for the sensor, and how we are going to adjust it. I'll just move this so you can I'm going to move this so we can see how it actually modifies our robot. So we're going to change the offset of the sensor, just move it a couple of millimeters forward, and we're going to adjust the range. We're going to increase the range a tiny bit to 0.25 to make it longer. I messed that up so you couldn't exactly see what happens, but 0.2, 0.25 to just increase it forward a bit. The following two values we are going to adjust. So the first is the radius from this point to this point, and we're going to change that to be significantly smaller, 0.0051. Sorry, I messed that up, so that's not the distance from this point to this point, it's from this point to this point here, and we wanted that to be nearly the same point as it is here, so we can move that. And finally we see that the sensor is hitting the floor. We don't want that, so we're going to modify the angle of the sensor from 90 degrees to just 30 degrees. Great. And then we're going to just adjust the detection parameters. There's nothing to change here much. We're just going to disallow detections that are smaller than 0.1 meters. So anything that's closer than this won't be detected. To avoid, for more complex geometries, we don't want a sensor detecting the robot itself. Okay. And the next sensor we're going to add is going to be vision sensor. So we're going to go add vision sensor, and we're going to add the perspective type. Has that been added? No, I don't see it. So add vision sensor perspective. There we go. And we can see the vision sensor here. We can see the cone of its detection. We're going to also modify it by moving it to basically the same position that our proximity sensor was. Yeah. Here, and as we did with our sensor, we want to rotate it. So we're going to rotate it by 90 degrees here. So now it's filming forwards, and we're going to rotate it additional 90 degrees here. This won't change what we see, but it's going to actually rotate it in a way that the picture is in the right orientation when we see it. As we did with the proximity sensor, we're going to need to adjust the vision sensor here. So here are the parameters that we have. We are going to adjust the resolution to 256, and we're going to set the clipping plane to 1. Okay, instead of, and this will limit the size of the sensor. We can just show you how that works. So let's say we set it to 2. It's going to increase the range. We don't want it necessarily that big, so we can limit it. In case you have trouble with processing this, if you're doing something with pictures, you can obviously lower the resolution to make everything go a bit faster. So after we have added our vision sensor here, we need to add a view that's going to let us see what's going on. So we're going to right click onto our scene here, and we're going to add a floating view. The floating view is currently empty, so we're going to right click on it, and we're going to go under view and select associate view. We select the vision sensor, so we have a vision sensor here. We're going to associate it, and we can see that right now we have something here that we can see. We can test that by adding a primitive shape such as cuboid. Let's make it like this and translate it. We need to run the simulation, and we can see that we have that added to the vision sensor. We can modify the view and process this within the programming. We're going to show how to do that in our next exercise.